frictionless part, again, please note the keyword here, frictionless, is moving at 6 meters per second on the horizontal surface. Just before it starts up, a ramp that rises vertically 1.5 meters from the top to the bottom. Set zero height to be at the bottom. Okay. We want to calculate the kinetic energy, potential energy, and mechanical energy of the cart as it starts up the ramp, and also calculate the kinetic energy, potential energy, and mechanical energy which reach the top of the ramp. Okay. By the way, we calculate the speed of the cart which reaches the top of the ramp. This problem, okay, in fact, our final goal is just to calculate the speed of the cart which reaches the top of the ramp. And I break them into many small steps because I would like to think about all the calculations game we are playing here involves two kind of stuff. The three equations we introduced there. Also, the definition for each quantity. Okay, like one, in fact, we always place with the two C's. Like here, you have one of the three equations here, mechanical energy conservation. But you still need to pay attention to for each term, they have some definition. So how do you write down K naught, U naught? And here I would like to think about, to calculate these quantities, or these K naught, U naught, E naught, this is, you need to think about those. Sometimes you can just use the definition of that quantity, directly calculate it. K equals to 1/2 mv squared, U equals to mg y, E equals to K plus U. And sometimes, if you cannot directly use the definition, you need to calculate them from the equation, so indirectly, right? Like here, to calculate K, we didn't use K equals to 1/2 mv squared because we don't know V. The indirect way to calculate is that in this equation, if we know K naught, U naught, U, we can calculate K. So I hope you think about this general stuff. So now, what happens is that you have a ramp, a cart, okay, starts from here and finally reaches here. So this is our initial state A. This is our final state B. In part A, we are going to calculate the kinetic energy, potential energy, and the mechanical energy at the initial state. So K naught, U naught, E naught. We want to calculate these things. And here, with part B, we want to calculate K, U, and E. So the final kinetic energy, final potential energy, and final mechanical energy. We want to calculate all of them. Any question here? Now, let's first look at A. If we want to calculate K naught, U naught, E naught, let's check how many of them can be calculated directly by the definition. By the way, we set 0 at the bottom. K naught, first let's check, can we calculate it from the definition? By definition, it should be 1/2 mv naught squared. So, can we calculate from this equation directly? Basically, do we know mass and the initial velocity? Yes, mass equals to what? 2. What is the initial velocity?
6 meters per second.
6 meters per second. So you can calculate directly. So it's 1/2, 2, 6 squared, so it's 36 joules. Okay. So that's K naught, initial kinetic energy. Okay? Now let's look at U naught. Can we calculate from the definition? The initial potential energy. Potential energy here. What's that?
There's no Y, so that's mg y naught.
0, okay. Mg y naught equals to 0 here. Y naught equals to 0. And y equals to, what's the height of the 1.5? Okay. So U naught can be directly calculated as 0 joule by definition. Now, how do we calculate E naught, the mechanical energy and the initial point. Okay, by definition, it's the summation of the kinetic energy and the potential energy. So K naught plus U naught equals to 36 joules, right? So the three initial quantities can be calculated directly from the definition. Now let's look at part B. Let's first check kinetic energy equals to 1/2 mv squared by definition. But can we use this definition to calculate the kinetic energy K? Do we know the final velocity V? We don't know it, so it doesn't work. Okay, now let's look at U naught. So let's go to look at U naught. Can we calculate it directly from the definition?
U naught or U? U naught or U?
Oh, U. Final potential energy. It's mgy equals to 2 times 10 times 1.5. So it's 30 joules, right? So this is the final potential energy. You can directly calculate it. Now, the mechanical energy, okay, it cannot be directly calculated from the definition K plus U because we can't directly calculate K so far. We don't have K so far. Okay. Now let's look at so that means the four quantities can be calculated directly from the definition. And the other two quantities, E and U, has to be calculated from the conservation law. Okay? So, which quantity should we calculate first? K or E? E. Okay? Now let's look at how to calculate E. So, this, of course, is the conservative system, similar to that, because we don't have frictional force. We have only normal force, gravitational force, but normal force doesn't do work, right? So WNC equals to 0. Mechanical energy conserved. So you have E conservation. So mechanical energy is a conserved quantity. So from this fact, can you tell me what is the value E? 36, because if it's conserved, E final has to be the same as E initial equals to 36. Right? And then, can you tell me what is K? Okay? If you look at E, by definition, is K plus U, right? So K must be E minus U equals to 36 minus this equals to 6. So this is the final kinetic energy, K equals to 6 joules. So instead of using the definition of K 1/2 mv squared, we use the equation, conservation law to calculate. Now, we want to calculate the final velocity from which quantity it can be computed. Okay, you know K equals to 1/2 mv squared, final velocity V. So you get 6 joules equals to 1/2 multiplied by 2 multiplied by V squared. So you can solve for V. So V squared equals to 6 and V equals to square root of 6 joules. Okay?
It's not 33.
K equals to 6.
Oh.
Okay? Not K naught. Be careful which quantity you are talking about. Here you have a bunch of different energies. Okay? Initial kinetic energy, final kinetic energy, initial potential energy, final potential energy, initial mechanical energy, final mechanical energy.
That's meters per second, right?
Okay, any question here?